Welcome. In this video, we're going to look at one of the problems under velocity time graph. So here is the diagram that we've been given, or rather, this is the diagram that we've been given for a speed time graph. And then we're told to find the maximum velocity, the acceleration, total distance traveled, and the deceleration in the last 2 seconds. So this is the question that we're going to look at in this video. So here, what we're going to do is we're going to begin with the first one. So let us do solutions. So we have for the first one, the maximum velocity. So this is 0. So this axis, it is for velocity, and this one, it is for time. Then in speed or velocity time graphs, this one, the line that is slanting, or rather the line that slants upwards to the right, it represents the acceleration. Then the flat line on the speed or velocity time graphs represents the constant speed or velocity, and the line that slants downwards to the right, it represents the deceleration. So this is acceleration, this is constant velocity, then this is deceleration. So this is what we need to know. Then the total distance is actually equal to the area under the shape. So let us begin with the question A. So this is for velocity. So we have 0 until we get to this point. So we are told to find the maximum velocity, and as we can see from the diagram, the maximum velocity here is 10. So maximum velocity is equal to 10. The units for velocity, meters per second. So this is how the first question must be handled. Then the second one, we are told to find acceleration. Now we know that the gradient on velocity time graph or a speed time graph represents acceleration. And acceleration, we know that by definition, it is the change in final velocity, the change in velocity. So final minus initial velocity over time. So the final velocity that we have here, it is this one. So in the first 5 seconds, an object is accelerating. So the final velocity is 10. Then the initial velocity, that is where it is starting from. So starting from 0, so minus 0 over. The time given here is 5. So acceleration will be equal to 10 minus 0 is 10 over 5, which will give us 2. The units are meters per second squared. So the acceleration will be 2 meters per second squared. Now we can go on to find the distance, the total distance traveled. Now this is the question that encompasses 2 methods of solving it. We can either use the trapezium rule, or we can solve it part by part. We find the area of this, and area of this, because the distance traveled is the same as, or is equal to, the area under the shape of the graph. So here, so let's say part C, total distance is equal to area under the shape. So the shape that we have here is a trapezium. So we're going to use the trapezium way. So area is equal to, the formula is half A plus B, then times H. So from this, our A is from this point to this point. Then our B, which is this one, is from this point to this point. Then our H is from this point to this point, or this point to this point. So what we're going to do here is we're going to plug in the values. We know that. Okay, so we have half. Then our A is from 5 to 8. So it is 8 minus 5, which will be 3. Plus our B is 0 to 10, so which is 10 minus 0, which is 10. Then our H is from this point to this point, which is 10. So times 10. So from here, half. Then in brackets, we're going to have 13, then times 10. So from this, so 2 into 10, it is 5. 5 times 13, it is 65. The distance is equal to 65. The units, meters. So that is how this must be That's how it must be handled. Now, the units for area, it is meter squared. But since we're looking at the distance, and we know that the area under this one, it is equal to the distance under the shape. So we just need to consider this as just the 65. So this is equal to 65 meters. So this is the distance. So from here, we can sum it up now to find the deceleration in the last 2 seconds. To find its deceleration, we just use the same concept of acceleration v minus u over t, changing velocity over time. So here, when an object comes to rest, the final velocity, so v will be equal to 0. Then the initial velocity, it is this velocity that is coming from here, so which will be a 10. So u will be equal to 10, okay, meters per second. So we plug in here, we have 0 minus 10 over 2. So we're going to have negative 10 over 2, which will give us negative 5 meters per second squared. So the deceleration is 5 meters per second. If you want to write acceleration, you can say acceleration is equal to negative 5 meters per second squared. Or if you want to write deceleration, or simply d, this must be 5 meters per second squared. The negative, if we write as deceleration, we don't need to indicate a negative because it is the name itself tells us to say it is a negative acceleration. Thank you so much for watching the video.